Hi everyone. So in this video we are going to see our assignment 1. Okay, so first assignment we are going to see. So I will show you the questions first. So this is the first one. This is second and third question. Fourth, fifth, sixth, seventh. You can pause the video and solve on your own. 8th, 9th, 10th, 11th, 12th, 13th, 14th, 15th, 16th, 17, 18, 19, 20, 21, 22. This is a very good question. And 23. Okay. So these 23 questions are there. We will solve one by one. First one. Whichever the statement is true, y is given as a XOR b XOR c XOR d XOR e XOR f. So y can be used as odd number of ones detector or even number of ones detector. Y is equals to a XOR b XOR c XOR d XOR e XOR f. So what is this? This is XOR expression, right? This is XOR operation. Why this is XOR operation? Number of inputs are even. Number of inputs are even. If the number of inputs are odd, then it could have been XNOR operation as well. Because I told you for odd inputs, let's just say A XOR B XOR C, that would be equals to A XNOR B XNOR C. But number of inputs are even, and XOR operation is known as odd numbers of ones detector, right? Odd number of ones detector. So this option would be correct. Odd number of ones detector. If it would have been something like this, A XOR B XOR C XOR D XOR E. If this would have been the case, then both A and B would have been correct, because this could be odd number of ones detector as well, and this can be equal to this as well. So both are same. If both are same, then this is XOR operation. XOR operation is known as odd numbers of ones detector, and XNOR operation is known as even number of zero detector. How would you remember? Okay, XOR operation. If I have odd number of ones, that means 1 XOR 1 will be 0, 0 XOR 1 will be 1. So that I can call as odd number of ones detector. And then XNOR will be even numbers of zero detector. So if this was the case, then both options would have been correct. But here 6 inputs are there, so this option is wrong. Okay. Let's see other options. The number of possible input combination for y equals to 1 is 32. So we need y equals to 1. We need y equals to 1. So if you need y equals to 1, then what can be the case? There is only one 1. Only 1. If there is only one 1, then your y will be 1. Only 1 and rest all are 0. Basically 1 XOR 0 XOR 0 XOR 0 XOR 0 XOR 0. So only 1 is there, then output will be 1. If there are only 3 ones, only 3 ones, if there are only 3 ones, 1 XOR 1 and then rest all are 0, then output will also be 1. And if there are only 5 ones, because you need odd number of ones, what you need odd number of ones, so only 5 ones, right? So out of these 6 you need 1 6C1. Basically what can be the case? If A is 1 and B is 0, B is equals to C is equals to D is equals to E is equals to F is 0, then A is 0, A basically B is 1 and then rest all are 0. This could be the other case. Then C is 1, rest all are 0. D is 1, rest all are 0. So that could be 6C1. Out of these 6 variables, one of the variables should be 1. Or 6C3, that 3 variables, 6C3, 3 variables should be 1. That means A is equals to B is equals to C is equals to 1 and rest all are 0. Or A is equals to B is equals to D is equals to 1, rest all are 0. Or A is equals to B is equals to E is equals to 1, rest all are 0. Or A is equals to B is equals to F is equals to 1, rest all are 0. Or B is equals to C is equals to D is equals to 1, rest all are 0. So these kind of condition can be there. More condition can be there. B is equals to C is equals to E is equals to 1, rest all are 0. B is equals to C is equals to F is equals to 1, rest all are 0. So these kind of condition. So 6C3. Out of these 6, we need to choose 3 variables which are 1. So 6C3, right? Plus 6C5. So out of these 6 variables, I can choose 5 variables which are 1 plus 65. So that would be the correct answer. So what is the value of 61? That is 6 only. What is the value of 63? So 6 into 5 into 4 divided by 6. So that is 20. Basic concept of PNC it is. So 63 is 20. Plus 65 will also be 6. So what is the answer? 32. So for y equals to 1, to get y equals to 1, there are total 32 combinations. So this option is correct. Now what are the total combination of A, B, C, D, E, F? Total combination. Total combination of A, B, C, D, E, F. Basically, A can have two values, 0 or 1. B can have two values, 0 or 1. C can have two values, 0 or 1. This also can have two values. This also can have two values. And this also can have two values. So all can have two values, right? 0, 1, 0, 1, 0, 1. So what all are the total combination? So total combination are total combination. So total combination is 64. Out of these 64, 32 times you are getting 1. So you are getting 0 another 32 times, right? So this option is also correct. So the number of possible input combination for y equals to 0 is 32. For y is equals to 1, you are getting 32 times. Then y is equals to 0, you will get 32 times only, because total combination will be 64. If there were two variables, A and B, so how many total combination were there? 4 total combination was there. If there were 3 variables, then how many total combination were there? 3 variables, there were 8, right? 2 into 2. If there are 6 variables, then answer would be 2 to the power 6. That means 64. So total combination would be 64. So out of these 64, 32 times you are getting 1. So rest 32 times you will be getting 0. So this option is also correct. So this was a very good question. These kind of questions can come in your MSQ. So you use your brain correctly and these kind of problems will be solved. Okay, let's move towards the next one. A XOR B, this function is given. How many NAND gates are required to implement the function? So in these kind of problems, first task is to reduce it. So let's solve this. Y is equals to, what is A XOR B? That would be A B bar plus A bar B plus B C bar plus B bar C plus C A bar plus A C bar, right? Okay then. So if I take B bar as common, then A plus C I am getting here. Then if I take B as common, then A plus C bar I am getting common. B common, A plus C bar. Sorry. If I take B common, then A bar plus C bar. And B bar I took common, so I am getting A plus C. B I am taking common, A bar plus C bar. And from here, what I can take common? I cannot take anything common. So let's not take this as common. Something different will happen for sure. So XOR operation is there, no? This should not be XOR operation here, because in XOR operation we are not getting anything. Actually, this will be XNOR operation. Okay, the question is wrong. This should be XNOR operation. XNOR operation should be there. I'm really sorry for this mistake. This should be XNOR operation. Okay, otherwise we are not getting anything. So this should be XNOR operation. So if we are doing the XNOR operation, then what we will get? So A bar B bar plus AB plus B bar C bar plus BC plus C bar A bar plus CA. So can I write it? AB plus BC plus CA plus A bar B bar plus B bar C bar plus C bar A bar. Do you remember one thing? That AB plus BC plus CA is self-dual, right? Is a self-dual function. This is self-dual function. Then if I write this as y, what is this? This is y bar. What was the complement of AB plus BC plus CA? Just go to the last lecture. Just see the 2 slides back. 2 slides back you will see what is the complement of AB plus BC plus CA. That is this only. So y plus y bar is 1. So your answer is 1 only. So how many NAND gates required? 0 NAND gate. You need one, direct one, a constant value, supply. One is VDD, the supply. So you need 0 NAND gates required. So there is 0 NAND gate required. Okay, so there was an error in the problem. Here it should be XOR operation. So in XOR operation, we got to know that AB plus BC plus CA, A bar B bar plus B bar C bar plus C bar A bar. So this is Y, then this is Y bar. So Y plus Y bar is 1. Let's solve the next one. What will happen to this one? These two are in parallel. So B plus C and D plus E are in series. Sorry, D plus E is also in parallel. So D and E is also in parallel. So D plus E. Then both will come in series. So multiplication. Then this much of switch and switch F, these are in parallel. So plus F. And then which one will come in series? This one will come in series. So this one will come in series. So multiplication A. So this we have already seen, switching circuit. B plus C into D plus E plus F into A. So that is the answer. Okay. Let's see this one. AB plus AB bar C plus A. So AB plus AB bar C. What this can be replaced with? AB plus C. Say yes or no? X plus X bar Y. That would be X plus Y. So this can be replaced with AB plus C. So now what you need to find? AB plus C plus A. So A common will come, 1 plus B plus C. So answer is A plus C. So this is the answer. Okay, very easy. AB plus AB bar C. So AB plus C, A will come in common. A will come in common. So 1 plus B will be remaining. Here, from here you will get 1. From here you will get B. So 1 plus B. So A plus C is the answer. Let's solve this one. Reduce the following expression. So A bar plus B into A bar plus C. This can be replaced with A bar plus BC. Say yes or no. A bar plus BC bar, sorry. A bar plus BC bar. Did you understand this? A bar plus B. X plus Y into X plus Z is equals to X plus YZ. So this is what we are doing here. A bar plus B plus A bar into A bar plus C. So A bar plus BC bar plus A bar B bar plus A bar C bar. See the bar of B is present, and then in the multiplication there is C bar, here it is A bar. So A bar C bar is present, yes. So this term is redundant. So this term will be gone. So what we are left with? A bar plus BC bar plus A bar B bar. Now here A bar is coming in common. So A bar into 1 plus B bar. From here I will get B bar plus BC bar. So what I am getting? A bar plus BC bar. So A bar plus BC bar. That's the correct answer. A bar plus BC bar. Okay. So A bar plus BC bar plus A bar B bar is also, let's just say if this was also an option, then it would not be correct. Okay, because we need to write down the reduced expression. So reduced expression is this, A bar plus BC bar. That is the correct answer. Okay. Let's move to the next one. Reduced expression will have how many literals? How many literals will be there in the reduced expression? So first we need to reduce it. So y is equals to A into B plus C bar. Now you need to take bar. How will you take it? Simply by taking the dual. So if I take the dual of A plus B, it would be A plus B. Then individual bar I can take. Individual bar I will be taking. And here I will get, then plus will be replaced with dot, A bar plus C. Right? So A, B plus C bar. This will be replaced with A bar plus B bar C. Say yes or no? Right? A bar plus B bar C, because X plus Y into X plus Z, X plus YZ. So A bar plus B bar C. Are you getting this point? I need to take the complement. So how will I take the complement? By the concept of dual. So I will be taking the dual A plus B into A plus C bar. But I need to take individual bar. So A bar plus B bar, A bar into C. So A bar plus B bar C. So if I solve it here, A into B plus C bar into A bar, A into B plus C bar into A bar. Right? Because C bar into C will be 0 only. C bar into C will be 0 only. Now A into B will be AB. A plus A bar will be 0. So this will be the final answer. So how many literals we are having? 2. So answer is 2. Okay, reduced expression. C bar into C is 0. So this time I did not write. Now A into B is AB plus A into A bar is 0. So AB we are getting. So literals are 2. 1 and 2. This is 1, this is 2. 1 and 2, 2 literals are there. Reduce expression, reduce this one. So what we will get here? First reduce this one. So you need to take the complement. So how will you take the complement? You can go with the concept of a dual. So what will be the dual? A, B bar, C. Then individual bar we need to take. So A bar, B, C bar plus A into B into C bar plus A bar, B, C plus ABC. A bar, B, C, A, B, C bar, A bar, B, C bar. Okay. So what is coming in common? BC bar is coming common here. BC bar is coming common here. So it would be A plus A bar plus here what is coming? BC is coming common here. So it would be A plus A bar here again. So BC bar and A plus A bar is 1, A plus A bar is 1. BC bar plus BC. So B is coming common here and C plus C bar will be 1. So answer will be B. Very easy, very straightforward. Answer will be B. Let's solve this one. Which of the following gate is redundant? Which of the following gate is redundant? What do you mean by that? So first we will find out the output expression and then we will get to know that which gate is not useful here. So let's see it. Okay, let's see the problem. So what you will get here? A bar. What you will get here? B. What you will get here? A bar B. And what you will get here? Here you will get A bar. And what you are getting here? B bar C D. Here you are getting B bar C D. So what will be your final output F? That would be A bar plus A bar B plus B bar C D. So A bar plus A bar B. Can I replace this as A bar and I take A bar I am taking common. So 1 plus B will be replaced with 1 only. So A bar plus B bar C D. So in the final output this is coming and this is coming, but this is not coming. That means this gate is not useful at all. There was no use of this gate because A bar B has been gone. A bar B has been replaced with A bar only. So gate 2 is redundant gate. So in these kind of problems you need to see what is being reduced. This is being reduced. So this gate is not useful. So gate 2 is redundant. Okay. So this is the answer. Let's solve this question. PQ, RS bar, PQ, 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 PQ. What you are seeing here? PQ is coming in common. PQ is coming in common. So let's take PQ as common. So RS bar plus RST plus R bar S plus R bar S bar plus R bar ST plus RS plus R bar S bar T. Now look at these terms. RS bar, R bar S, R bar S bar plus RS. Do you remember something? PQ, what did I tell you? R S bar plus R bar S plus RS plus R bar S bar. What that would be? Rest of the terms are RST, R bar ST, RS. Do you remember the Venn diagram? What this was? A B bar. This was A bar B. This was A B. And what this was? A bar B bar. So all combined was what? I told you to remember this expression. A bar B plus A B bar plus A B plus A bar B bar. That is equals to 1. So what this will be equals to? This will be equals to 1. 1 plus anything. 1 plus anything will be 1 only. 1 plus anything will be 1 only. So this can be reduced to PQ only. That's it. This is the answer. 1 plus anything is 1. So this will be reduced to PQ. So this will be used again and again. that a bar b plus a b bar plus a b plus a bar b bar is 1. Okay. Now there are 100 XOR gates. So x plus 1 XOR, this will be x bar. X bar plus 1. Oh, wait a minute. Okay. This is x bar plus x. X bar plus x will be 1. Then 1 plus x, again x bar. Then again x bar plus 1. X bar plus x, sorry. Basically, what is happening? X XOR 1 is x bar. X bar XOR x will be 1. 1 XOR x will be x bar. X bar XOR x will again be 1. So after every even XOR gate you are getting 1. So after 100 what you will get? 1 only. So this is the answer. Are you getting this point? X XOR 1 is x bar. X bar XOR x is 1. 1 XOR x is x bar. X bar XOR x will be 1. Again it will keep on going. So after every even gate you are getting 1. So this is also even. So after this even gate also you will get 1 only. So that is the answer. Okay. Let's see this question. This is also very interesting one. A bulb in staircase has 2 switches. One switch being at the ground floor, another switch being at the first floor. So this is the scene that staircase is there. Okay. So once this is switch 1 and this is switch 2 and bulb is somewhere in between. This is your bulb. Now what they are saying, the bulb can be turned on or turned off by the bulb can be turned on and also can be turned off by and of the switches irrespective, and will not come by one of the switches, by and will not come by one of the switches irrespective of the state of the another switch. The bulb can be turned on or turned off by one of the switches irrespective of the state of the another switch. The logic switching of the bulb resembles as which gate? AND gate, OR gate, NOR gate or XOR gate. So if you are not able to solve this particular problem, then no issue, we will solve it now. So let's understand the meaning of this. So let's just say you are standing here. Now you are going up. So this is the case 1 where I am going up. So if I am going up and I am writing down the condition of switch S1 and S2. S1 and S2 and the respective output that I need. So if I am going up, what I will do? I will turn on the switch S1 because I need light, because I need to go up. So I need to turn on the bulb, right? I need to turn on the bulb. So I will click. Initially what is the scene? S1 is off, S2 is off, both are off. Then bulb is also off. Now I am going up. So I will click on S1. That means I will turn on switch S1. So if I turn on switch S1, S2 is off only. Still bulb should turn on, right? Initially S1 and S2 were off. Now I need to, S1, S2 are off, bulb is also off. Now I need to go up. If I need to go up, then what I will do? I need to turn on the switch. Here there is a switch. I will turn it on. If I turn it on, that means bulb should lit. Bulb should give me light. So bulb should give me light. S2 is off only. Now I am walking here. I walk, and I walk here. Now I have reached here. So now I don't need light. So I need to turn off this bulb. I need to turn off this bulb. So what is the condition of S1 now? Condition of S1 is this, because it has been turned on. When you were going up, you turned it on. So switch S1 is already on. Now what I will do? I will click switch S2. That means I am actually turning it on. But what I want as my output, that my bulb should turn off. So this is what I want my output. Are you getting this point or not? Initially I was on the ground floor. This is the ground floor and this is the first floor. I want to go up. In the staircase, there is in between there is a bulb. This is S1, this is S2. Okay. If I want to go, initially S1, S2 both are off, so bulb is also off. Now if I want to go up, That means I need to turn on the S1 switch. If I turn on the S1 switch, S2 is already off. So bulb should lit. So bulb is lit and it is giving me 1 as output. That means bulb is lit now. So 1 is on. Basically, I am taking 1 as on and 0 as off. This is what I am taking. So bulb is lit now. Now I am going up. So S1 has already been on. Now I have reached here. Now I have reached here. Now if I have reached here, I do not need the light. I do not need the bulb. So I will turn it off. That means this is already on. This one is already there. Now I will click on this again. I will click on 1 again. So 1 and 1 should give me 0. That means bulb should be off now because I have reached here. Now there could be other case as well. Let's just say I am coming down. The other case could be if you are coming down. So from the up side I am coming down now. So I am coming down now. So this is S2, this is S1. Bulb is somewhere here. So again I will make the truth table. So if I am coming down, so this condition is not related with this one. Independently I am taking it, okay, independently. So independently I am taking it. So initially both switches are off. This condition is not related to this one. Independently I am taking it, independently, that the guy need to come down. So initially both switches are off. That means bulb is also off. Now I need to come down. That means I need to turn on this bulb. So I will click on S1. Now I am coming down. Okay. So I am coming down now. So I will click on S1. So I need my output to be 1. I need the bulb to turn on and S2 is already off. Now I have reached here. So I do not need bulb now because I have reached to the downstairs. I have reached on the ground floor. I do not need bulb to be on. So now I will click on S1. And I want my bulb to be off. So no matter what was there on S2, when I have reached here, I want my bulb to be off. So I will just simply click on S1. And my bulb will be off. So these two truth table I am getting. 0, 0 is giving me 0. 1, 0 is giving me 1. 0, 1 is giving me 1. And 1, 1 is giving me 0. So based on that, what did I get? The complete truth table. What I am getting? In the complete truth table, what I am getting? 0, 0 is giving me 0. 0, 1 is giving me 1. 1, 0 is giving me 1. And 1, 1 is giving me 0. So which gate is that? EXOR gate. Which gate is that? EXOR gate. So there is another name of EXOR gate. So EXOR gate is known as switching gate as well. Okay. Or what we call it? Non-equivalence detector. This we have already seen, right? Non-equivalence detector. No, not switching gate, sorry. Staircase switch. This is known as staircase switch. Sorry. EXOR gate is known as staircase switch. Because in staircase we got to know that in staircase we use EXOR gate. So it is known as staircase switch. Non-equivalence detector. What was the other name? Odd number of ones detector. So these are the names of EXOR gate. Okay. So you can remember this. So did you understand this question? This was a very good question. Going up and going down, two different conditions we took. You can, first I went up and then I came down. You can take the condition that first you come down, then you go up. Both independently we took and we got to know that this is the truth table we are getting. So based on that, we got to know that it is a EXOR gate. Shall I explain it again? Quickly I will explain it. S1 both were off. Okay, so my bulb was off. I need to turn on the bulb now. So S1 I turned on. So bulb should turn on. So 1, 0 should give me 1. Now I have reached S2. So I do not need bulb to be turned on. So I will click on 1. So 1, 1 should give me 0. So that's it. Now I am coming down. So coming down, both bulbs are off only. If both bulbs are off only, so y should be 0. If I am coming down, that means I need the bulb to be turned on. So I will click on S1. So I will click S1, then S1 will be, if I click, sorry, I will click S2. So if I click on S2, then bulb should lit. So if bulb lits, then I am coming down, and then if I have reached to the downstairs, then I will click on S1 again to turn off the bulb. So this is the truth table I am getting. Okay, so this is the XOR gate. Okay, let's move towards the next question. What is the output? Very easy question. AB bar we are getting here. This is AB bar, and what this would be? This is B, and what is this? C. Here what you will get? AB bar into B. So what is your output? Y is AB bar. AB bar can be sold as A bar plus B bar into B, and then into C, and then whole bar. Okay, this is AB bar into B into C and then whole bar. So what I am getting here? A bar B C whole bar, right? So this is one of the option. This, since this is MSQ, so A plus B bar plus C bar. This is also one of the option. Just I sold the bar. Okay, so A bar plus B bar plus C bar. So this is also one of the option. Very easy problem, very straightforward. What about this one? So you can solve it by any method, but what I will tell you. Look, what this would be? A XOR B bar and then another bar. So this bar and this bar will get cancelled, no? A XOR B bar and then another bar. A XOR B bar and then another bar. So what this would be? A XOR B. And what about this? This will also be A XOR B. Right? Now if I say A XOR B is Y, so what I will get here? Y XOR Y bar and then another bar. So what I will get? Y XOR Y only. And what is the value of Y XOR Y? 0. So what will be your output? Output will be 0 only. Basically the scene here is A XOR B XOR A XOR B bar and then whole bar. So one bar can be taken as whole bar only. So answer would be A XOR B XOR A XOR B. A XOR B XOR A XOR B is 0. So this is the correct answer. Okay, very easy problem. Which input combination will make Y equals to 1? So you can do it on your own. Y equals to 1 you need. So at least C has to be 1. Because if C is 0, then whole expression will be 0. So C has to be 1. Now, if this needs to be 1, so both A and B cannot be same. If both A and B are same, then it is gone. So this is gone, this is gone. This could be one of the chance. So 1 0 is 1. What would be 0 XOR 1? That would be 0. So this is also 1. Right? What about this one? 0 XOR 1 will be 1. 1 XOR 1 will be 1 only into 1. So 1 into 1 into 1. So this is the correct answer. Okay. Very easy problem. Very straightforward. So answer is D. This question. So I told you in feedback they will not mention anything. The shown NAND gate has a finite non-zero delay TD. The circuit will act as what? I told you one thing, they will not give you anything, like they will not give you any input. So you have to assume that because of some noise, let's just say here 0 input came. If 0 input came, then 1 into 0 is 0. So 1 into 0 is 0. 0 bar will be 1. So this 1 will travel here again. So this 0 will go to 1. Then 1 into 1 will be 1. And 1 bar will be 0. So this will go to 0. Now this 0 will travel here again. So 0 will come. 1 into 0 is 0. 0 bar is 1. So this will again become 1. So 1 will again go here. So what is this? This is being a stable multivibrator only. Right? This is a inverter. This is acting as an inverter only. This is fixed. Let's just say this input is A. So A into 1, that is A bar only, no? So this is acting as an inverter. So one simple inverter is there. Basically one simple inverter is there. 0 1 0. Basically one simple inverter is there and output is fed back to the input. So this circuit is acting as a stable multivibrator. Okay, this is acting as a stable multivibrator. And they will not say that first I break the loop and I apply the input, then I again make the loop. Nothing like that. They will not give that. You have to assume that there will be some input. You could have assumed 1 as well. So here you will have 0, then 0 would come, again 1 would come, 1 again 0 would come, then again 1 would come. So it will keep on going. So this is a astable multivibrator. Okay, so answer is A. Let's move to the next one. B bar C plus AB plus, let's see this, what this is equals to. B bar C plus AB plus AC bar. So can we apply consensus theorem? 2 bar are there, no? C bar is there, CC bar, 2 bar is there. 2 bar are there, so we cannot apply consensus theorem here. Because CC bar is also present and BB bar is also present. So we cannot apply consensus theorem here. So what we can do? So B bar C plus, I can take A as common. So this would be B plus C bar. Say yes or no. So it would be B bar C plus A. Can I write this as B bar C bar? B bar C bar, right? B bar C bar. That would be B plus C bar. So basically, if this is X plus A X bar, what that would be? X plus A. X plus X bar A. So X plus A. What is X? B bar C plus A. B bar C plus A. Or this can be written as basically B bar C plus A, or you can say A plus B bar C. So this can be written as A plus B bar into A plus C. So A plus B bar into A plus C. This is the correct answer. So this was a very good question. You need to think here. B plus C bar, then I can write this as B bar C bar. So that would be X plus X bar A. So this could come X plus A. So A is A only, X is B bar C. So A plus B bar into A plus C. So answer is B option. Okay. So these kind of things you need to think. Let's solve this question. So first I will tell you how you can do it wrong. So A XOR A bar plus B. So if you are solving in this manner, A XOR A bar plus A XOR B. So what this would become? 1. Right? A XOR A bar would become 1. 1 plus A XOR B. 1 in addition to anything will be 1 only. So this is wrong. I told you one thing. This cannot happen. I told you this. A XOR B plus C is not equals to A XOR B plus A XOR C. I told you this thing, right? If you remember it. So this is wrong. So how we will solve it? By simple method we need to solve it. So A XOR A bar plus B. So that would be A as it is, bar of the second one. What that would be? AB bar. Bar of this. Bar of A bar plus B. What will be the bar of this? AB bar. Plus second as it is, bar of the first one. So AB bar plus A bar plus A bar B. Right? A bar plus A bar B. So from here we are getting A bar only. So A bar plus AB bar. So that would be equals to A bar plus B bar. And that would be equals to AB bar. Okay. So answer is C. Answer is C. Okay. So this A bar plus A bar B, A bar I took common. So this is reduced to A bar only. So A bar plus AB bar. So that would be A bar plus B bar. And that can be written as AB whole bar. So answer is C. Now see the next question. Assuming that variables and their complements are available. Variable and their complements are available. Then the minimum number of 2 input NOR gate needed to implement 2 input XOR gate. 2 input XOR gate. And 2 input NOR gate required. So what is the expression of XOR gate? A bar B plus AB bar. But you require NOR gate. So for NOR gate you don't need that. What you need? For NOR gate you need product of some form. Product of a sum. So A bar plus B bar into A plus B. Now what they are saying? Variables and their complements are available. That means A, B A bar, B bar. All these are available. If all these are available, then how much it will require? So this is simply like C plus D into A plus B. So how much this requires? 3. So answer is 3. A plus B into C plus D. We have seen it, right? A plus B into C plus D. How will you implement using EXOR gate? So how will you implement this using NOR gate? So how much did we required? 3. Do you remember this? We required only 3. So answer will be 3 here. A plus B into C plus D. If you clearly remember, A plus B, C plus D, and then it goes here. Then I put 1 bar here, 1 bar here, 1 bar here, 1 bar here. So this is 1, 2, and 3. So answer would be 3. Okay. So by this as well you can do in examination that you will require 3 only. So answer is 3. Let's see this question. What possible combination of A, B, C to turn on the LED? So to turn on the LED you need high output here. You need high output here, right? Because this N side, this is a simple diode. Do you know the working of diode? Basically I will tell you. If this is high and this is low, then this LED will turn on. And if high low, I should have written, not positive negative. And if this is low and this is high, then it would be off. Both are high, then also it would be off. Then also it would be off. And if both are low, then also it would be off. So only condition to turn it on is we need 1 here. Our target is to get 1 here. That's it. So how we will get 1? To get 1 here, let's check. A is equals to 0, B is equals to 0. So this will be 0. If A is 0, B is 0. So this will be 0. If this is 0, then certainly this is 1. So this will work. If A is 1, B is to turn on the LED, right? Yeah, okay. If A is 1 and B is 0, then this will be 0. And if this is 0, this is certainly 1. So this will also work. If A is 1 and B is 1, then this will be 1. And if B is 1 and C is 0, so this will be also 1. So 1, 1, 0. This will be 0 now. Now this will not work. And this should be MSQ. And if A is 1 and B is 1 and C is also 1, so this will be 1, 1, 1, 1 would also be here 0. So this will also not work. Okay, let's check back again. Let's check back again. So A is 0, B is 0, so this will be 0. If this is 0, then certainly this will be 1. So there is no doubt LED will turn on, right? If B is 0, then certainly this is 0. So there is no doubt. A is 1, B is 1, so this will be 1. 1, 0, this will also be 1. 1, 1 is 1, this will be 0. So not turn on. A is 1, B is 1, C is 1. So 1, 1, 1, this would be 0. It will not turn on. Okay. So only 2 options are correct, A and B. Easy question, very straightforward. Let's see this question. If A XOR B is equals to C, then B XOR C is equals to what? So what we need to find? B bar XOR C. That can be replaced with B bar XOR C whole bar. And if A XOR B is equals to C, then I told you one thing, that B XOR C will be equals to A. So B XOR C will be equals to A. So that will be equals to A bar. Very easy, right? Now what this will be equals to? A bar XOR B. A bar XOR B. So this bar can be taken as whole bar, right? 1 bar can be taken as whole bar, and then another bar is there, XOR C bar. So this can be replaced as A XOR B C bar. So this bar is there, so this can be taken as whole bar. So this can be taken as Y XOR C bar. Y XOR C bar. So that can be replaced as Y XOR C. So Y XOR C can be replaced as A XOR B XOR C. And then there is whole bar. Then there is this whole bar. So if there is this whole bar, this is very interesting. Now, is this correct option? No, this is not correct option, because I told you for 3 variables A XOR B XOR C, is equals to A XNOR B XNOR C. So this is not correct. Okay. So now what we can do? So this is the final answer we are having. Basically another bar was there, right? Another bar was there. This another bar was there. So this bar is coming here. Are you getting this point? Basically this bar and bar was gone. So A XOR B I am left with. XNOR C, and then there was bar. So another bar I took. So A XOR B I am taking as Y. So Y XNOR C bar, that would be Y XNOR C bar. So basically this is Y XNOR C only. Y XNOR C only. This can be replaced with Y XNOR C as well, or I can replace it with Y XOR C bar. Y XOR C bar. So so basically A XOR B XOR C bar is there. Now I can take bar on any of the variable, right? On any of the variable, I can take bar something like this, because that can be whole bar as well, right? Are you agreeing to my point? I can take bar on any of the variable, or what I could have done, I could have taken bar like this as well, A XOR B. So I am taking bar on this only, XOR C, because whole bar will be there. Basically, if A XOR B this is there, then I can take A XOR B whole bar. So if whole bar is there, then I can take bar on one variable as well. So this is what I am doing. Now what this will be replaced with? A XOR B XOR C. So this is the correct answer. Okay. Are you getting this point? So this way we need to solve. We need to match the option. Other possible answer would have been also there. What all possible answer are there? This could also be one of the answer, or this could also be one of the answer. So other possible answers are there. This is also correct. This is also correct. This is also correct. So these kind of questions can come in MSQ. So smartly you need to solve. Are you getting this point? How I am solving it? Just take the bar and then you need to match the option that where I should take the other bar. So if whole bar is there, then you can take the bar on one variable. If bar is there on the one variable, then you can take the whole bar. Okay, so option C is correct. Now let's see this question. Very conceptual problem. Very conceptual problem. So and you need to have basic idea of RC circuit. Okay, I am assuming you have studied network analysis, basic idea of RC circuit. So here only I will ask you, if this is R, this is C, and 5 volt is there, then what will happen? This capacitor will charge, right? And let's just say my capacitor has been charged to 5 volt. My capacitor has been charged to 5 volt, and now this node is grounded. This is your R, this is your C. So what will happen? The capacitor will discharge. So this much of transient you need to know. That's it. 5 volt is there, 5 volt will charge the capacitor. If 5 volt R is there, then there is no battery, so 5 volt will be discharging. This much of transient you need to know. That's it. Okay, let's solve this problem now. What they are saying, the inverters are driven off a supply of 2 volt. So we studied about inverter in last videos. In second last video, I guess, we studied about inverter. How will we actually make these inverters? From the CMOS. From the MOS we will make these inverters. Basically we will connect our MOS in this manner. So this is how we will make the inverter. When we study logic family, I will tell you how do you make AND gate, OR gate, NOR gate, NOT gate, all kind of gates we will make with the help of these IC, not IC, with the help of semiconductors, or with the help of MOSFETs, or with the help of BJTs. With the help of these devices we will make all the inverters. So to run these devices we need a supply. This supply we need. So this supply is 2 volt. So this is running at 2 volt, and another supply they did not mention. Basically 2 volt, and then there would be ground. There could be negative supply as well. If this is VDD, there could be minus VDD as well. So other supply will also be there. One is VDD, other supply could be ground or anything. So if they haven't mentioned, I will assume the other supply is ground. Now what they are saying, and their threshold are at mid supply. Threshold are at mid supply. Let's just say this is V in and this is V naught. Threshold are at mid supply. That means threshold is 1 volt. Mid supply means 2 by 2. That means 1 volt. So what do you mean by that? This is an inverter. If your V in is greater than 1 volt, if your V in is here, if your V in is greater than 1 volt, then it will give output to 0 volt. Then it will give output to 0 volt. Why 0 volt? If Vin is greater than 1, output will be 0, because for higher value, inverter will give lower output. Basically, what does it mean? That if your Vin is greater than 1 volt, then your inverter will assume it to be high value. And if your Vin is less than 1 volt, if your Vin is less than 1 volt, if your Vin is less than 1 volt, then your inverter will assume it to be low value. So it will give you high output. And what is your high output? High output is 2 volt. High output is 2 volt. So this is the threshold. This is the threshold. This is threshold. So threshold of inverter is 1 volt. If your input is greater than 1 volt, that means it will assume it to be high value and it will give your output to be 0 volt. And if your input is less than 1 volt, then your inverter will assume it to be a low value and will give output as 2 volt. Are you getting this point or not? So if my Vin is greater than 1 volt, my output will be 0 volt. And if my Vin is less than 1 volt, then my output will be 2 volt. So that's the thing. Now what is happening in this circuit? You are applying the input at t equals to 0. At t equals to 0, you are applying the input. But for t less than 0, there was no input, right? So let's make the circuit for t less than 0. I will just copy this circuit. I will copy the circuit as it is. And I will tell you how it will look like for t less than 0. So for t less than 0, what was happening? This input was not there, right? This input was not there. This was shorted. This input was not there. This capacitor was having 0 voltage. This capacitor was having 0 voltage because capacitor was uncharged. So capacitor was having 0 voltage. So if capacitor was having 0 voltage, so 0 voltage was here. So if Vin is less than 1 volt, that means here what you will get? 2 volt. Now because of this 2 volt, this would have been charged. This capacitor would have been charged. And capacitor would have been charged to 2 volt. And if Vin is greater than 2 volt, that means output would have been at 0 volt. So this is the scene for t less than 0. Are you getting this point or not? For t less than 0, this capacitor is having 0 voltage. Since this capacitor was having 0 voltage, so this inverter, at the input of the inverter, you are having 0 voltage. So this will give as output at 2 volt. If this is giving output at 2 volt, that means this will charge to 2 volt. And if here you are having 2 volt, that means this inverter will give output as 0 volt. So this was happening at for t less than 0. Now for t greater than 0, what will be the scene? For t greater than 0, what you have done? You have applied some input now for t greater than 0. You have applied some input and this has been charged. This is already charged to 2 volt. This was charged to 0 volt only. Now what they are asking? At what point of time V0 goes to VDD? VDD means, here I should have mentioned, VDD means 2 volt. VDD is equals to 2 volt. So at what point of time V0 T goes to 2 volt? So you need this output to go to 2 volt. Tell me when it will go to 2 volt. At what point it will go to 2 volt? Let's just say this potential I am calling as Vx. When Vx goes down to 1 volt, when Vx goes down to 1 volt, at that time your VDD will go to 2 volt. Say yes or no. Basically, when Vx goes down to 1 volt, or you can say 0.9999999 volt, at that time V0 goes to 2 volt, right? Because I told you if Vin goes below 1 volt, V0 goes to 2 volt. So this is our target. Our target is to find when this will discharge to 2 volt. That's it. Now for it to discharge, for this capacitor to discharge, what is the voltage you require here? You require voltage here to be 0 volt. For this capacitor to discharge, you require here voltage to be 0 volt, right? And when you will get 0 volt here? When this is charged above 1 volt. Say yes or no. So you want this cap to charge to 1 volt. You want this cap to charge to 1 volt. And if it is charged to 1 volt, then it will go to 0. 1 means basically 1.000000001. If it is charged to this much of potential, then it will go to 0. And if it goes to 0, then it will start discharging. Say yes or no. So this is the scene. So first we will charge this capacitor. This capacitor will charge. So what is the charging equation? Do you remember? Do you know that? So charging equation is 4 into 1 minus e to the power t by tau, and tau is RC. RC is 1 second. So now we want it to charge to 1 volt. So how much time it will take? ln 4 by 3. ln 4 by 3 second. So at ln 4 by 3 second, this will be charged to 1 volt. ln 4 by 3 second, this will be charged to 1 volt. And if this is charged to 1 volt, that means this will go to 0. Now this will start discharging. So what is the discharging equation? That is 2 into e to the power minus t by tau. Tau is 1. And we want it to discharge to 1 volt. Right? We want it to discharge to 0.99 volt or 1 volt. So how much time it will take? This time is t1, this time is t2. So how much time it will take? ln 2 time. So what is the total time? So at ln 4 by 3 plus ln 2, after this much of time, this would have been discharged to 1 volt and this would have gone to VDD. So this time is 4 by 3, ln 4 by 3 plus ln 2. So 4 by 3 plus into 2. So that would be ln 8 by 3. So this is our answer, ln 8 by 3. So at ln 8 by 3 time, this would have gone to 2 volt. Are you able to understand this point or not? I will again explain it. Okay, very good question. Capacitor is initially having, here it is having 0 voltage, so this will be at 2 volt. This is at 2 volt, so capacitor would have been charged to 2 volt. If this is 2 volt, V0 would have been 0, right? Now at for t greater than 0, you have applied an input. What input you have applied? 4 volt. Okay, so 4 volt you have applied. Now this capacitor can charge now, right? But what we want our output to go to 2 volt. That means we want this to decrease to 0.99 volt. Basically, we want this potential, Vx potential, to decrease. When it will decrease? When you are having 0 volt here. When you will have 0 volt here? When this is charged to 1 volt. So our first target is to charge this to 1 volt. So how this will charge to 1 volt? So 4 into 1 minus e to the power minus t by tau. So in ln 4 by 3 second, it will be charged to 1 volt. Okay. Now if it is charged to 1 volt, that means it is going towards 0 now. So this has gone to 0. Now this will discharge. So this will discharge to 1 volt. How this will discharge to 1 volt? 2 into e to the power minus t by tau. So to 1 volt it will discharge. So how much time it will take? ln 2 second it will take. So in ln 4 by 3 second, this is charged to 1 volt, and then in next ln 2 second, this has been discharged to 1 volt. So if this has been discharged to 1 volt or less than 1 volt, then Vout will go to 2 volt. So this is what we wanted. So ln 4 by 3 plus ln 2, answer would be ln 8 by 3 seconds. So this was a very good question. Okay, I hope you must have understood it. Now let's see this question. Which of the statement is true? What do you think? What kind of circuit is that? Astable multivibrator, monostable multivibrator. What kind of circuit is that? This is an MSQ. So what will happen? Initially, capacitor is having 0 voltage. Initially, this is having 0 voltage. So this 0 voltage will come here. If 0 voltage is there, then this will be 5 volt. So if 5 volt is there, then this capacitor will charge. So capacitor will first charge. Okay. Then if capacitor is first charging, capacitor will first charge. So let's just say, like, I don't know the supply, I am assuming supply to be 5 volt. So capacitor is charged and capacitor will charge to 5 volt. Now what will happen? This 5 volt will come here, this 5 volt will come here, and inverter is there, so this will go to 0. Now this is charged to 5 volt. Now this 5 volt will discharge. This 5 volt will discharge now. This 5 volt will discharge. So this has discharged. Now what will happen? Since this has discharged, so this will go to 0 volt. So this 0 volt will again come here. Since again there is an inverter, so 0 volt will be converted to 5 volt. Now again this capacitor will charge. So again this capacitor will charge. Then again discharge. Then again charge. So in this manner it will keep on going. Right? So this is what? This is a astable multivibrator. Just simply charging, discharging. There is no stable state. Plus, minus, plus, minus, plus, minus, plus, minus, it is going. There is no stable state. So this is astable multivibrator. So this circuit, monostable it is not, the bistable it is not. This circuit produces a periodic square wave if RC value is very low. So this also I should have mentioned. Basically, if RC value is very low, then there will be fast charging and fast discharging. What I mean to say, if RC value is very low, then this waveform will go something like this. Very fast charging will be there, and then very fast discharging will be there. So very fast charging will be there, very fast discharging will be there. So it is kind of a square waveform only. So it will produce a periodic square waveform if RC value is very low. So charging, discharging will be there. Okay. So first it will go to 0, then 5, then again 0, then this will go to 5, 0 and 5. So the capacitor will charge in the same manner, 5 volt, then this 5 volt will come here, then it will be 0, then this capacitor will be discharged. So this 0 will come here, this will go to 5 volt, 5 volt is here, the capacitor will charge, then 5 volt will go here, then this will be 0, so the capacitor will discharge to 0. So 0 to 5, 5 to 0, 0 to 5, 5 to 0. In that manner you will have a square wave, and this is a astable multivibrator because going up, coming down, going up, coming down. In that manner we are going. Okay, then I hope you must have understood. Okay, so yeah, that's it. That's the end of the assignment. I hope you must have enjoyed the level of the problems. So we are solving good amount of problems and good level of problems as well. Let's meet you in the next lecture.